Welcome back, everybody. Today we're taking a deep dive into, I guess you could say, the heart of OS2,
Yeah,
the Control Program Interface, or as
yeah.
the cool kids called it, the CPI.
The CPI.
Um, and we've got with us someone who knows a thing or two about this.
Oh, I've dabbled.
So we've got a stack of manuals and guides, and even a book on OS2 design,
Oh, wow.
spanning from like 1989 to 97.
The golden age.
Yeah.
That's awesome.
So our mission is to like really understand what the CPI was all about and why it was so important for OS2 developers.
Yeah, it was so important back then for OS2.
And I guess from what I've read, it seems like it was like if you're gonna build a house,
Right.
it was like the language you needed to know to build a house.
Yeah, it really was the core foundation that you had to know to do anything in OS2.
So it was like their Rosetta Stone in a way.
Yeah, exactly. It was a way to get into the operating
So
system.
you're telling me this CPI was like the Rosetta Stone for programmers back then?
Yeah, basically. And it didn't matter what kind of hardware you were running on underneath, it was standardized.
Okay.
So you could write your code and it would theoretically run on any machine that was running OS2,
Oh wow.
which was a huge deal back then.
Yeah, because I guess back then every machine was kind of its own snowflake.
Right. Every machine had its own little quirks. So this was a really big deal.
Okay, so we got standardization, which is awesome. But what could you actually like do with the CPI?
Well, you could do just about anything you wanted an application to do.
Really?
Managing memory, creating threads,
Yeah.
for multitasking, even something as simple as moving the mouse pointer around the screen.
Oh, wow.
It was all done through the CPI.
Now you mentioned multitasking,
Yes.
and I know OS2 was known for multitasking.
Yeah, absolutely. It was one of the first.
So how did the CPI like help with that whole, experience?
Well, let's say you wanted to build an app that could download a file in the background while you kept working on something else. You would use what was called a DOS create thread function to spin up a new thread to handle that download process.
Okay.
And the CPI would manage all the tricky parts of making sure that both of those threads played together nicely
Got it.
so that your system didn't lock up.
So that's how they avoided, the whole system freezing up.
Exactly.
Okay, cool. And so it's almost like you had like a team of little helpers in the background making sure everything was running smoothly.
Yeah, you could think of it that way.
That's pretty cool.
Uh-huh.
I mean, I'm starting to see why developers would have loved this.
Yeah, definitely.
Um, so you mentioned memory management before too.
Right.
So like take, for example, you're building like a photo editor
Okay.
and you need to load these huge image files.
Right.
How would the CPI, help with that?
Well, you would use a function called DOSALOCMEM, and this would basically request the memory that you needed from the system.
So it's like ordering room service for your code.
Yeah, exactly.
That's a great way to put it. You're like, I need this much memory, and CPI would, deliver it to you.
That's a great way to put it. And, you bring up a good point because how did this all work behind the scenes?
Yeah, how did the CPI make all this magic happen?
Well, it all came down to what were called request packets.
Request packets.
Yeah.
What are those?
Basically, they were these specially formatted messages
Oh, okay.
that your code would send to the OS2 kernel.
Okay, so I'm picturing like a little digital envelope
Yeah.
that, the coder writes a little message, sticks in the envelope,
All right.
and then sends it off to the OS2 kernel.
That's a great analogy. And then the kernel, which is kind of like the brains of the operation,
Yeah, the big boss.
receives that request and knows exactly what to do with it.
Okay.
Now, one of the coolest places where all of this happened was in something called the strategy section of a device driver.
Device drop. Now, hold on. Wait a minute.
Yeah.
We're talking about applications here, right?
Right. But that's the beauty of the CPI.
Okay.
It wasn't just for applications. You see those little programs that control your hardware, like your graphics card or your hard drive.
Okay.
They all had to talk to the OS, and they all did that through the CPI.
Oh, wow. I see. So it's like one language to rule them all.
Right. Everything was speaking the same language,
Yeah.
apps, device drivers, everything.
Okay. That's pretty impressive stuff. So like, let's say I'm building that photo editor we were talking about, and I want to do like some fancy image effects.
Okay.
But at the same time, I'm also saving this huge file to the hard drive.
Right.
How would the CPI help me pull that off and like keep everything running smoothly?
Well, in that scenario, the CPI would be your best friend.
Okay.
It had functions specifically for things like DMA,
DMA.
direct memory access.
Oh, yeah.
Think of it like a high-speed rail line for data.
Okay.
It allowed your hard drive and your graphics card to talk directly to each other without bogging down the CPU.
So while the user's sitting there admiring all the fancy image effects, data is just flying back and forth thanks to the CPI.
Yeah.
I'm starting to get the picture here. So all of this was built on top of, the brains of the machine.
Right.
The processor architecture, the Intel 80 by 86.
Right. And the CPI was designed to really leverage all those features, particularly something called the ring security model.
Ring security mode, like, are we talking like Lord of the Rings type rings?
Not quite, but it is kind of like a hierarchy.
Okay.
Think of it as these concentric circles of protection.
Okay.
And the most sensitive stuff was the operating system kernel that lived in ring 0.
Okay.
The inner sanctum.
The inner sanctum. Okay.
Then you had applications and less critical things running in the outer rings.
So this was all about keeping the core of the OS safe from any, rogue programs.
Exactly. It was all about security. And this is where it gets interesting.
Okay.
Device drivers, they needed direct access to the hardware.
Right.
So they also operated in that privileged ring 0.
Okay.
But the CPI made sure that even though they had all that power, they still had to follow the rules. They communicated through these very specific channels.
So the CPI wasn't just about like convenience for the developer.
No.
It was about keeping the whole system stable and secure in a multitasking environment.
Right. It was like the conductor of an orchestra.
Wow.
Making sure that all the different instruments played together in harmony and nobody stepped on anybody's toes.
That is a great analogy. I like that a lot.
Yeah. It was a really beautiful design.
Very cool. All right. So.
Yeah. So, and this whole design, it wasn't static. As OS2 evolved
Okay.
from those early versions that had that limited DOS support,
Right.
To the more powerful later, warp versions.
Yeah, the warp.
The CPI evolved along with it.
So it wasn't just, a one and done.
Oh, no.
They kept adding to it.
They kept adding to it every new version.
So new versions, new functions, new capabilities.
Exactly. New tools in the toolbox, basically. And that's one of the big reasons why OS2 is so appealing to developers.
It was constantly growing and evolving.
It was always getting better.
Okay, so we've been, really diving deep into all this technical stuff.
Right.
But, let's take a step back for a minute.
Sure.
And, why should someone,
Yeah.
Who's not like a hardcore OS2 nerd,
Right.
really care about the CPI?
Well, that's a great question. And I think the reason is that the CPI was such a marvel of engineering.
Okay.
And a lot of its core principles, like abstraction and standardization
Okay.
and a focus on security, these are still relevant to how we build software today.
So it's almost like studying, the classics.
Yeah.
Like you don't write in Latin anymore.
Right.
But understanding Latin
Can really help you
helps you write better.
understand how language works. Yeah, exactly.
So are there other modern echoes of the CPI that you can think of?
Yeah, tons of them take Windows, for example. A lot of the core concepts of the Windows API,
Right.
the way that applications talk to the operating system, they have roots in the CPI.
So even though, OS2 is not really around so much anymore,
Right.
its legacy kind of lives on.
It lives on, yeah, in a lot of ways.
That's pretty cool. Are there any other, less obvious examples of where this, CPI stuff is carried over?
Yeah, I mean, think about those little icons that you see everywhere online, like
Right.
the hamburger menu or the search bar.
A shopping cart?
Yeah, they've become standardized.
Yeah.
Because they work.
Yeah, you know what to expect.
Exactly. Users know what to expect and how to interact with them.
So that consistency really helps us, navigate the digital world.
Absolutely. It makes everything much easier to use.
So was there a downside at all to all this standardization that the CPI, pushed?
Well, standardization can be a double-edged sword.
Okay, how so?
On the one hand, it promotes consistency and code reusability.
Okay.
But on the other hand, it can lead to situations where developers might feel limited by what the CPI allowed them to do.
So it's like a trade-off.
Right.
You gain stability and portability,
Right.
but you might lose some flexibility in the process.
Yeah. It's like choosing between taking a well-worn path. Okay.
Or going off into the jungle.
Yeah, one's a lot safer.
Right.
The other one's a lot more adventurous.
Exactly. And, speaking of trade-offs, there were other reasons why OS2, despite its innovative CPI,
Right.
didn't really become the dominant operating system.
Yeah, that's the million-dollar question. I mean, if OS2 was so technically advanced, what happened?
Well, one factor was the hardware requirements, early versions of OS2.
Okay.
They needed a pretty powerful PC for the time.
Yeah.
And not everybody had that.
Okay.
And another issue was just the lack of applications. A lot of developers were hesitant.
Right, they didn't want to jump in yet.
Exactly. They wanted to see if it was going to be successful first.
And so it's that chicken and the egg problem, right?
It's the classic chicken and egg problem.
You need the users to attract the developers, and you need the developers to attract the users.
Right.
And then, of course, there was Microsoft,
Wow.
who were really pushing Windows hard at the time.
Absolutely. And while Windows wasn't as technically sophisticated as OS/2,
It was a lot more affordable,
okay.
and there were a lot more applications available for it.
So it was kind of a perfect storm of, hardware costs and lack of software
Yeah.
and just fierce competition.
And timing, sometimes timing is everything.
Yeah, it really is. I guess it's kind of a reminder that, technical brilliance alone
Right.
doesn't always guarantee success.
That's a great point, and it's something that I think we can all learn from.
Yeah, I think so too.
Yeah.
So, okay. So we've talked about what happened to OS/2,
Yeah.
but, let's not dwell on the what ifs.
Right.
We've learned a lot about this fascinating, part of software history.
It's been an amazing journey.
Yeah. And hey, maybe some of these OS/2 ideas will make a comeback.
You never know.
You never know, right?
Anything is possible.
Anything is possible.
Yeah.
So, let's shift gears a little bit here
Okay.
and talk about what the CPI can teach us today.
Okay.
So, pop quiz time. What would you say is like the biggest takeaway
The biggest takeaway,
from our little CPI deep dive?
I would have to say it's the power of abstraction.
Abstraction.
The CPI did such an amazing job of shielding developers
Right.
from the complexities of the underlying hardware
Right.
and gave them a much cleaner, more consistent way to interact with the system.
It's almost like, developers don't have to reinvent the wheel every time.
Yeah,
They
exactly.
want to write some new code.
Yeah.
They could just focus on, the logic of their app
Right.
and then let the CPI handle all that messy low-level stuff.
That's a great point, and it really reminds me of how modern programming languages and frameworks work today.
Yeah, you don't really have to understand how all the bits and bytes work
Yeah.
underneath the hood.
Right, you don't have to be a hardware expert to build amazing things.
That's a great point. Okay, so abstraction is a big win.
Definitely.
Are there any other lessons from the CPI that we should keep in mind?
Yeah. Think about the importance of standardization.
All
The
right.
CPI provided that unified interface
Right.
for both applications and device drivers, which was essential for OS/2's stability and portability.
Yeah, and we see that today,
Yeah,
right?
you see it everywhere. It's like having a universal translator that allows different parts of a system to communicate seamlessly.
And that's kind of the goal, right?
It's all about making software work together.
Breaking down those silos.
Breaking down the silos,
Yeah.
exactly.
Okay, so abstraction standardization. Two big wins
Two big wins.
for the CPI. But were there any cautionary tales
Yeah. I mean, there's always...
or things that, looking back, we should maybe avoid when we're designing systems?
Yeah, that's a great point. One potential pitfall is becoming too reliant on a specific platform
Okay.
or technology. And, OS/2, despite all of its strengths,
Yeah.
it was ultimately tied to that IBM PC architecture.
Right.
And as the tech landscape shifted, it struggled to keep up.
Right. And, that kind of brings up a point that we haven't really talked about yet, which is IOCTLs.
Oh, IOCTLs, those are interesting.
What are those all about?
Well, think of them as these kind of secret back channels for communication.
Okay.
With device drivers, they allowed developers to send these very specific commands to devices,
Okay.
going beyond what the standard CPI functions allowed.
So if you needed to do something really unique with a piece of hardware,
Exactly.
you could use IOCTLs to get that done.
IOCTLs gave you that power.
So IOCTLs are like cheat codes for the OS.
Yeah, you could think of them that way.
I like that.
Yeah.
But back to your point about, being too platform dependent, is that still a risk today?
Absolutely. It's so easy to get caught up in the excitement
Right.
of the latest and greatest technology.
A new shiny thing.
Right, but you always have to keep in mind that the tech world is constantly changing.
Yeah.
What's hot today might be obsolete tomorrow.
So stay flexible, keep learning,
Keep learning.
and be ready to adapt.
Be ready to adapt. Absolutely. That's great advice.
So anything else we can glean, I guess, from the CPI's journey?
Well, one final thought is that OS/2 and the CPI, they were products of their time.
Yeah.
They were designed for a world where PCs were becoming increasingly powerful and complex and, in a lot of ways, the challenges that they addressed.
Yeah, like managing resources, ensuring security, providing a good user experience.
Exactly. Those are even more relevant today.
Than they were back then.
With cloud computing and mobile devices and the Internet of Things.
It's kind of amazing how those fundamental ideas
They keep coming back.
just keep popping up over and over again.
It's really a testament to the ingenuity of the people
Right.
who designed these systems. They were laying the groundwork for the future.
That's a great point. So I guess what we're really saying is that, even though OS/2 might be a thing of the past,
Yeah.
the ideas behind it,
Those ideas live on.
Those ideas are still very much alive and well.
Absolutely.
So let's, in the next part, let's kind of shift our focus, I guess, from the past
Okay.
to the present
Sounds good.
and explore some of these ideas in more detail and see what lessons the CPI can teach us today.
I'm excited for that.
So we've been traveling back in time, exploring this world of OS2 and its control program interface, the CPI.
The CPI.
But before we come back to the present,
Right.
let's just take a second and appreciate the legacy of the CPI.
It's more than just a set of technical specs.
Right.
It's a philosophy of design,
Okay.
a way of thinking about how software interacts with the world. And, these ideas, they're still relevant today.
Give me an example. Like, how is this CPI philosophy still relevant?
Think about the design of a user interface, like for a website or an app.
Okay.
One of the CPI's core principles was abstraction.
Right.
Hiding complexity from the user.
Okay.
A well-designed UI does the same thing. It presents this clean and intuitive experience without overwhelming the user with a bunch of technical details.
Because it's like that saying, good design is invisible.
Exactly.
You don't notice it because it just works.
Right. And another principle was standardization, in the UI world.
Yeah.
This translates to using familiar design patterns, consistent layouts, common UI elements.
It's like those icons we see everywhere.
Exactly.
The hamburger menu, the search bar, the notification bell.
Yeah, and those have become almost universal because they make the digital world so much easier to navigate.
Right. You know what to expect no matter what website or app you're using.
Exactly.
Okay. And the third key principle, flexibility.
Right.
That's got to be crucial for modern UI design as well.
Oh, absolutely. A good interface should adapt to different screen sizes, different input methods, user preferences.
It's all about creating that seamless experience, whether you're on a desktop, a tablet, or your phone.
Right. And, thinking about this whole idea of interfaces,
Yeah.
it goes way beyond software.
It does.
Human communication is all about interfaces.
Wow.
We use language gestures, facial expressions,
Right.
all these tools to connect and share ideas.
That's a great point.
Yeah.
So if we think about the CPI principles
Okay.
applied to human communication, abstraction would be, choosing the right level of detail to convey the message clearly.
Okay.
Standardization would be like using shared language,
Right.
cultural norms.
Exactly.
We can understand each other.
Right.
And flexibility would be, adapting your communication style.
Right. Depending on who you're talking to
fit the situation.
Exactly.
Wow. That's a really cool way to think about it. So, when communication breaks down, whether it's because of misunderstandings, cultural differences, even just, bad intentions.
Right.
The consequences can be pretty serious.
They can be. It's almost like those cryptic error messages we used to get in OS2.
Right.
But instead of a computer crashing, it's relationships, collaborations, even societies that suffer.
So it really underscores the importance of investing in those human connections. Building bridges of understanding.
Absolutely.
Clear, empathetic, adaptable communication that's essential for a healthy society.
No, it is just like the CPI was essential for a healthy operating system.
Wow, we've come full circle.
Yeah.
We started with all this technical stuff about the CPI.
We did.
And now we're talking about, its impact on human interaction.
It's amazing.
I love how this deep dive has taken us on such an unexpected journey.
It's all about the power of ideas.
So as we wrap things up here, we're left with, I guess, kind of a big question.
Yeah.
How can you apply these CPI principles to your own life, to your work, your interactions with the world?
I think the key is to be mindful of those interfaces, those points of connection, and strive to make them as clear, consistent, and adaptable as possible.
That's great advice. So on that note, I guess we'll leave you with a final thought.
Okay.
Just like the CPI connected applications and hardware in the world of OS2, we can use these principles to build those bridges of understanding in our own lives and create a more harmonious,
a more
interconnected world. So until next time, keep exploring, keep questioning, and keep diving deep.
See you next time.